Morning everyone. My name is Noor Basha, Senior Marketing Manager at Winwire Technologies. Welcome to today's webinar session on Azure Container Service. Before we start, let me highlight a few housekeeping items. During the webinar, please feel free to post questions and we will try to answer as many as we can at the end. Presentation and recording of this session will be shared to you in next 24 to 48 hours. So with that, I would like to introduce you to today's session speaker, my colleague, Mr. Amit Dubey, who is the Director of Cloud and Mobility at Winwire Technologies and brings over 15 years of experience in the IT industry. He is a Microsoft Azure certified professional. So with that, I would like to turn it over to Amit. Amit, over to you.
Thank you, Noor. Hello, everybody, and welcome to the webinar on Azure Container Service. And as Noor introduced, my name is Amit Dubey. I'm the Director for Cloud and Mobility Business at Winwire Technologies. So I'll be walking you through this session today. So on the agenda, we have containers. So we're going to talk about what containers are, first thing. And then we are going to do a comparison between containers and virtual machines. So we'll see what are the similarities and what are the differences between those two. We're going to look at some of the advantages of working with containers. And then we are going to see how we can scale these containers and what is orchestration. I'm going to show you a simple demo where we are going to run an ASP.NET 5 application on a Linux machine as a Docker container. So this is something new that you might have seen. So far we have been running ASP.NET applications only on Windows. Now it has the flexibility to run on other platforms as well. After that, in the end, we'll be opening it to question and answers. So if you have any questions, as Noor said, you can type in the chat window and then we'll answer all of them at the end of this session. So with that, let's begin. Before talking about containers, let me introduce you to what is virtualization. So we are in an age and time today when the hardware capacity has increased tremendously. The amount of compute power, the amount of memory that you have is huge. So sometimes the applications are not able to use this resources that they have effectively. So what we have done is to overcome this. We have created like a concept called virtualization, where you dedicate a certain amount of memory, certain amount of compute to a particular application, and then you create similar sets on the physical hardware that you have got. So talking about virtualization, the first thing I think that comes to everybody's mind is about virtual machines. So you create a VM which takes a part of the physical hardware, like a certain amount of CPU memory, and then builds a machine on top of it. And then you can create multiple VMs on your physical hardware that you've got. So that is nothing but your one form of virtualization, that is creation of VMs. The other form of virtualization is basically what we are talking about today is containers. So containers are nothing but a package that consists of your application and all the dependent files that it requires to run the application. So all the libraries, the binaries, the environment, anything that your application needs to run except for the OS, that is packaged as one block and which is called as a container, right? So they are a solution to actually problems when you migrate software from one machine to the other. So ideally containers I think was created because like when you have code running on one machine, it's working fine, and when you move it to another, say when you're working at development and then you want to move it to staging or production, then if you want to do that, then many times what happens is your application might not run as expected. So there are some things that are missing, some files are missing, or the environment is not the same as the previous machine. To solve all those problems, containers were introduced. Like you can run the container, like if you install the container on one machine, it is guaranteed that it will run the same way on the other machine as long as it's installed properly. So that's what containers is all about. It's like one package that has everything required for your application to execute. Now, when you're working with containers, you need a software. You need a particular software that will allow you to work with containers. So say for example, if I want to install a container, remove a container, scale them up, scale them down, how do you do this? So there is something called as a Docker engine. What is there? that helps you do this. So it runs on a Linux host. Currently it's available only for Linux, and soon it will be available for Windows as well. So right now the Docker container actually runs on Linux, and then as I talked about, containers actually wrap up a piece of software, and the entire file system, including the code, runtime, tools, libraries, everything that you can install on the server. So that makes it like agnostic to environment. So it will work in any environment. Now, talking about Docker Engine, like it's an open source project. It was released in March 2013 and has been very popular since then. This is one of the container engines that you can easily install and work with. In the demo as well, we are going to use the Docker implementation for containers. As I told you, it's available for Linux right now, and soon it will be there for Windows as well. So it has CLI tools like PowerShell commands that you can run, command line interface, that you can run to work with the containers. And then it has a REST API that you can use to integrate with other applications as well. And then it has a low-level API. So what you can do is you can specify, like when you're installing a container on a machine, you can say that only this amount of memory or this amount of CPU it can use. So you can do that level of configuration as well when you're working with the Docker engine. So that's one of the implementation of containers. Let's compare virtual machines. Now you might have worked with virtual machines a lot, and you know what they are. So take for example this diagram that we have on the left. So you have a server, a physical server, which is having a host OS, so an operating system that is running on top of it. Now if you want to create a VM, so you either use hypervisor or Hyper-V as you call in Microsoft environment. So what Hyper-V does is it allows you to build a new virtual machine on top of the server that you're having. So whenever you build a virtual machine, so what it does is it comes along with its own OS, which is called as the guest OS. So if you build like two virtual machines, then you are having two guest OS. If you build 3, 4, so on and so forth, so many number of guest OS will be created along with the VM. So when you start a VM, you're actually starting it from the scratch, like you're booting the OS and then you're installing and running the application on top of it. And every VM is separate. Like you cannot have common things between two virtual machines, right? So you have to have the same libraries in each virtual machine that you install on your server. Whereas if you look at the containers, which is on the right side, so you have the server, you have the host OS, which is the common part, and then you have a Docker engine, which is the Docker engine that manages all your containers. Now let's see. So if you have an application which is running as a container, then you just deploy it on the host OS. So it occupies certain amount of memory and storage, but if you see, it is not creating its own operating system. So it is using the host OS that is underlying as the operating system. And then you can have multiple instances of your app A or app B. For example, if you see I have like 5 instances of app B running and 2 instances of app A running, and they are sharing the same binaries and libraries that are required, because basically they are the same application. So you can just have them as one piece that is shared between all the multiple containers that you're having. So as you can see, I can install more number of containers compared to the number of VMs that I can create on the same physical hardware, right? And I don't have to worry about like the guest OS, and the starting and stopping of containers is pretty fast compared to a VM, because it doesn't have the overhead of starting the guest OS. And memory wise also it's very lightweight, because you don't have the guest OS, because the operating system itself takes the majority of your memory, right, for the application. So if we remove that, I know it has the additional thing of the binaries and libraries and all those things, but comparatively, if you don't have the OS, it's much lesser, right? So the result is basically like faster deployment, less overhead, easier migration from one server to the other, and then faster restart. So all these are the advantages that you get with containers. So as we talked about some of the advantages, as I said, it's lightweight comparatively compared to VMs, because you're not having the guest OS along with it, and it's using the underlying host OS of the physical hardware that you're having. It's open source, so Docker containers are based on open standards, currently available for Linux distributions. So the code is available. You can have a look at it, or you can poke it and work on top of that. It's secure in the sense that, like, say for example, if I have a container and I install it on a machine, then all the files and all the resources that belong to that particular container, which are there in that package, can be accessed only by that container. This happens by a smart thing that your Docker engine does. It does something called as namespace isolation. So all the file system, all the binaries, libraries, or configuration files that you have in that container are accessible only by that container. So a separate container, a different container, cannot access the things inside another container. You can make that possible by making some changes, but normally by default, every container has its own space where it has its own file system and everything. So in that way, they are very secure. The other advantages of using containers is basically you can accelerate developer onboarding. Basically, what I mean by that is, say for example, if you bring in a new developer to your project, he doesn't have to worry about whether I have all the supporting files or frameworks or anything that is there, because if your application is running on a container, your developer can just start working on it without worrying about anything else, right? And it empowers creativity because they are not worried about the environment, the frameworks, and the dependencies. They can concentrate on just coding part. And then you eliminate environment inconsistencies because your container actually has all the environment details or the configurations that you need, so you don't have that. You can easily distribute and share your content across machines, and then you can scale easily. That means that if you instance of a container running, and if the load on that is increasing, you can just run multiple instances of the same containers on the same hardware that you have, and then bring in a load balancer to divert your requests. Easily remediate issues, because now that you know that all the other things are sorted out, you know that all the issues are related to the code itself, so you can pinpoint exactly where some issues are happening and then work on that. Another important thing is continuous integration. So when you work with containers, it also allows you to do continuous integration as you do normally with your repository. So say for example, if whenever you do a check-in, if you want your code to be deployed to a container, you can still do that. So whenever a check-in happens, you can write rules, and then based on that, you can deploy it on a dev or a QA server. And then from there, once it is tested, you can even move the same container to the production environment as well. So it does support the DevOps cycle as well. Scaling containers, as I talked about, you can scale containers. So if you have one container running and then that is not able to handle all the requests or the load that is there, if you want to increase the performance, then you can scale them up and down. So you can scale the containers to a higher level or a lower level whenever required, and then you can run multiple containers on a single machine. As long as you're working on a one machine, then everything is fine. You don't need anything additional apart from the Docker engine that you have on your OS. But if you're working on multiple machines, like say for example, if I am creating a container, now I can span or I can scale the container to a number of instances on one machine. But if it goes beyond that, say for example, if I need more containers than one physical machine can handle, at that point in time I have to bring in multiple machines, which is called as a farm, where you have more than one machines for you, and then you can span your containers across those machines. So when you're working with a farm, what you need is you need something to manage all those machines, right? The distribution, the load balancing, and all that to be handled, and that part is called as orchestration, right? When you're working with a farm in terms of containers. So Docker Compose is a library that you can use to actually scale up and scale down, for example, your containers. To manage the farm, what you have is your Docker Swarm. So it is a library that is provided by Docker that you can use to work with multiple servers. Then there is Mesos, the DCOS, which actually was present before Docker itself. Now they have added support to Docker. So it's a very mature platform that you can use to manage farms with your Docker environments. There are other things also available, which is Kubernetes, which is created by Google, that you can use. And then there is DICE. It's a PaaS platform to deploy and manage applications with Docker. So all these are actually available on Azure as well. So we're going to talk about that in a little bit. So orchestration is when you're working with the farm, and Swarm or Mesos is something that you will need to work with multiple servers when you're working with containers. So let's talk about Docker and Microsoft. Now you have full support of Linux on Azure environment, if you know, and then you have also support for building a Docker-enabled Linux virtual machine on Azure environment. So if you go to the Azure portal and then type for Docker, you will see that you will get a template, the Ubuntu template, which comes with Docker pre-installed. So you can just create a Docker machine, a Linux machine with Docker enabled in just a few steps. So you just use the template and provide the name, username and password for that, and you have a VM ready for you where you can deploy containers, right? So Microsoft has provided those images, and then they are going to be available, more images are going to be available on Azure soon. So that is how you can create a single machine on Azure. So, and as I talked about it, right now you only have Linux, but soon you will also have Windows servers available with Docker support. The Azure Container Service also provides you with farms. So if you want to create a single machine, that is fine. But if you want to create a farm with multiple machines, then you can do that as well. So you just select Azure Container Service as your template, and then when you choose that, you have to give how many number of servers you want and what is the orchestration mechanism that you want to use with these machines. So once you set that, everything is created for you. So it creates all the required machines with the configuration, and then it will create the orchestration platform as well that you can just start working with. So it's as simple as that. So you just choose the template and provide your configuration values, and then it does everything for you. So let's create a ASP.NET application, which is a part of our demo. So what we're going to do here is we are going to create a web application which runs on ASP.NET 5, which runs on your .NET Core framework. Now .NET Core framework is a subset of your full-fledged .NET framework, which runs on Linux as well. So it's a cross-platform, the .NET framework code. So before we do that, there are some prerequisites that you will have to do. So the first thing is you will have to install Docker Toolbox. It's available for Mac and Windows. Now we need this because we are not directly working on a Linux machine. I'm working on a Windows machine. So if you are doing that, then you will have to install a Docker Toolbox, which allows you to basically create a Linux VM on your machine, and then you can install containers on that Linux VM. So that's why you will use your Docker Toolbox. The second thing is, if you are working with Visual Studio to create an application like we will be doing right now, so I would recommend that you use Docker tools for Visual Studio. So this basically what it does is it enables your application for Docker containers. So once you do that, it adds all the necessary support files that you need for the application to be built and deployed as a container, right? You can do it without Docker tools for VS as well. You can write your own command line PowerShell commands and then build it and deploy it on a Linux machine which has Docker. Otherwise, if you use this, it basically makes it your job much simpler. So these are the steps that we are going to follow in the demo. So first thing is I'm going to create a new ASP.NET 5 application which runs on .NET Framework Core, and then I'm going to add the Docker support to it. And then once we do that, you will see that it will create a Docker file and a PowerShell file called as Docker task, which has all the tasks that you require to deploy and run the application on as a container. And then you can also run it from Visual Studio application as a Docker app if required. So let's switch to Visual Studio. All right. Let's create a new ASP.NET application. So new project. So we choose web, and then we choose ASP.NET Core web application which runs on .NET Core. This is important because we have to run it on a Linux VM. you cannot choose the entire .NET framework, right? So let me just say Docker demo. Okay. While the project gets created, let me go to PowerShell and then create a machine, a Linux VM for you. So let's choose the empty template for this. Say okay. Now, if you see my slide, the next one has this the steps that we have to follow to create a Docker machine and then deploy it over there. So the PowerShell command for that is docker-machine create and machine name. So let me give the machine name as Docker demo. So that's the machine name. So it will create a new Linux VM for us. While that gets created, let's go back to Visual Studio and then, okay, we have our .NET application ready here. So it just has output as one line. Let me change that to my first container app and run this once and see. So if you see now, I'm running it on IIS Express, which means that it's running locally on my machine on IIS Express that comes with Visual Studio. So it creates a temporary IIS and then it installs it on that, and then we can see it will say localhost and some port number on which you will see the output. But we want to run it on a Docker container, so we will do that as well. So here it's trying to create a machine and then it will generate an IP address for it. So meanwhile, our application is running. Okay, localhost, this is the port number on which it is running. So my first container app. So this is nothing special. I mean, you must have done this umpteen number of times. So we just created an ASP.NET application and then we are just outputting one line in the start which says my first container app, which is on IIS. But our intention is actually to make this as a container. So what I'll do here is I'll say, I click on this and I'll say add Docker support. Now you get this option only if you install your Docker tools for Visual Studio. So you have to make sure that you do that. So once you add Docker support to it, you will see that it will add additional files to our application. I'll just talk about it. So you see there are some files already added. So if you see here, it adds this file called as Docker file, which basically tells like what port this application should run on, and then it will open up that port for you, and what are the files that are to be copied when you deploy this application, and what is the name of the DLL. So right now we are saying it should run on port number 80 and we will leave it like that. Now you see interesting thing here, IIS Express changed to Docker, which means that I can directly run this as a Docker container from my Visual Studio itself, right? So the targets, the properties, if you see, this is important. Now by default, it gives the name of the machine as default. So if you have a different name, like here, if you see, we created the machine with the name Docker demo. So you will have to change this here if you want to run it from here. So you change the default to Docker demo, and then you have to restart Visual Studio if you change any of these properties, and then run the application so it will directly run on that machine. So we are not going to do that right now. I'm going to use the command line interface to actually deploy this application. So let's go back to the slides. So here is the next step. So now I have the application, I have created a machine. Now I have to deploy this on the new machine that I created. So this is the command that I will use to actually deploy that. So the name of our machine is Docker demo, and we are just using the Docker task that was created by our Visual Studio tools once we added the Docker support. Okay, so this is the PowerShell file that got created once we added Docker support to our project. So we are saying build environment release on this machine Docker demo. So I have to switch to the folder where this application is. So I will just do that. It's there in the folder called as Docker. Now what this will do is this will download all the libraries that you need. So basically starting from your .NET framework, .NET Core and other libraries that you have referenced in your project, everything will be bundled as a container, and then it will deploy that container onto your VM that you have machine that you have created, which is called as your Docker demo machine that you already have. So if you see here, it's now downloading the .NET Core framework, and then it's installing it on the Docker demo machine that you already have created, which is a Linux VM with Docker support. That's what we have created. So once this is installed, we can just run it and see that you can run your .NET application on a Linux machine. Okay, so successfully done. Now the last part is, instead of build, this time we have to change the command as run, because we have already built and deployed it. Okay. Let me just rebuild this and do that again. Looks like there was something. Just build this again. So what it is doing right now is, it's like, because we already ran this before, and stopping the previously used port number 80 and then starting this again. Okay, there it is. So my first container app. If you see the IP address, this is not localhost. This is 192.168.99.100, which is the IP address of the Linux VM that I created. So you can change this and redeploy it. You can see that it will be reflected here. I will just say on Linux. So I'll build this and deploy it again, and then you will see that we have a new message now. So Noor, we can open it for questions at this point.
Hey, thanks, Amit. Definitely, yes. I have a few questions already coming in. So the first is it possible to deploy a container on an Azure machine using same commands?
Yes. Basically, the only difference would be, like, here what I did was I said Docker machine create, which actually creates the machine on my local environment. So if you want to create a machine on Azure, use the commands that I have given here. So Docker machine, you have to give the Azure subscription ID and then the name of the machine. You can go like that, or there is a template available on GitHub. So you could use that to create the machine on Azure. So once you change this step with either of these two, then you can continue working same as we did just now. So if you see, we got the new message here, my first container app on Linux. So you see that you can easily deploy your changes to the container by just redeploying it with one line.
Thanks, Amit. Yep. So the other question is it possible to run Docker container on Windows machine?
Yeah, right now it is only supported on Linux, but soon it will be available for Windows as well. So that's why we have the Docker toolbox, which actually creates a Linux VM for us that we're using to run this container.
Cool, thanks. So the other question is, how is microservices different from containers?
Basically, what happens is the microservices is when you divide your application into small modules and then deploy them, and then you can scale them as needed. So if a particular module is getting heavily loaded, so you can just scale that module, right? So that is the concept of microservices. Now using containers, what happens is your concept of using microservices is amplified. So if you're working with containers, it becomes very easy for you to scale one particular container. So what you can do is you can have each microservice as a container that gives you the flexibility of scaling your selected microservice. So that they work hand in hand, basically, I would say.
Cool. Thanks, Amit. I know we are almost close to 9:30 now. So if we are done, probably we would just, okay, thanks, Amit. Okay, thanks everyone for taking time to join this webinar, and I hope you found it informative. As you can see on the screen, our next webinar is on Azure Search, which is on June 8th, 9 a.m. Pacific time. So we look forward to you joining to the next webinar. Thanks everyone for taking time to join this webinar, and have a good day. Thanks, Amit.
Sure. Thank you, Noor. Thanks everyone for joining. You have a great day. Thank you.